The last homework assignment was due last night, and today and Monday are just your days to ask questions and look at topics that will help you prepare for the final. I only got one sort of general question about a topic that someone wanted to go over. If there's other things people want to see, feel free to let me know as we go here. I had a request to talk about function transformations, which I think is a good topic to look at because that's something that applies to all across the course. We learned of function transformations really early in the semester, and we used it in just about every section. And on tests, I oftentimes ask you to graph things, and I'm going to ask you to graph things on the final. So it is definitely good to look at this. And maybe I'll try to relate what we learned in that first section to all the other chapters. So function transformations. Let me write down the main ones that we talked about way early on. So let's say f of x is a function. We can apply the following transformations. Let me break it down by vertical and horizontal. So vertical transformations would be multiplying on the outside of the function, multiplying by a constant on the inside of the function, or multiplying by -1 on the outside, right? These are all the vertical things. So that would be vertical stretch or shrink, depending on whether or not c is bigger than or less than 1. This is a oops, I said I was going to break it down by vertical and horizontal, and then I put them together. I'm sorry. Let's just keep going, though. This is a horizontal.
Hey, Professor, your screen's really blurry. I don't know if I'm the only one experiencing it, but I thought I'd mention it.
Let me hit looks good on my screen. I just hit the autofocus thing. You might want to, it could be an issue with your internet or your computer. Is anyone else having a blurry issue? It looks fine on my particular screen.
Yeah, it was blurry before, but it looks better now.
Okay.
Yeah, it's clear.
Okay, so when you multiply on the outside of the function, that's vertical. When you multiply on the inside, that's horizontal. Stretch or shrink. If you multiply by -1 on the outside, that is a vertical flip. If you do it on the inside, it's a horizontal flip. And then we can add a number on the inside or the outside. So this would move the graph up or down. So vertical shift, so up or down. And then if we do it on the inside, it becomes a horizontal one. So these are the 6 transformations that we learned early in the semester, and we've been using these in every section, right? We started doing it on like general polynomials, but we did it with exponentials and logs. We did it with trig functions. And so it all kind of like applies the same way. So like, for example, keeping this in mind, let's look at some CF of x1, so vertical stretch or shrink. So if we did CF of x where c equals 2, let's say. So let's look at like stretching graphs by 2. Well, if it's an x squared graph, that might look like this. If it's an x cubed graph, it would look like this. If it's a cosine graph, it would look like this. If it's an exponential, it would look like this. Trying to think of another one to look at. If it was an absolute value, it would look like this. All right, so in all cases, the 2 in each one of those situations is like separate from the function, right? So I can like cover up the 2, and then it's just an x squared. And so you're taking x squared and you're multiplying it by 2, right? Or you're taking x cubed and you're multiplying it by 2. Or you're taking the cosine and you're multiplying it by 2, right? In each one of these cases, it's going to take whatever the base graph is and vertically stretch it by a factor of 2. But I think the key thing to realize here is noticing how the 2 is on the outside, right? Let's look at a horizontal one and compare them. So let's do f of x plus c. Let's do c equals 3 in this case, just to have a different number. And let's do the exact same, let's use the same base functions, but let's do a horizontal one. And so instead of the 2, or in this case the 3, being on the outside of the function, it's going to be inside with the x on all those, right? So the x squared one would look like this, for example. The x cubed would look like this. The cosine would look like this. The e would look like this. So if someone gets a little tricky because the x is up in the exponent, right? So if you're going to add a number to the x, it needs to be in the exponent with that one. And then the absolute value, it would look like this. And so hopefully you can see, I'm hoping that this gives you an idea of the difference between vertical and horizontal stretching. Gosh, I messed this one up. I messed this up bad. Sorry. I wanted to multiply those things. When I put a plus, that would be a shift, but I wanted to do the stretching. I'm sorry. What I wanted to do was c times x. Terribly sorry about that. Same idea, except there's just not going to be a plus, right? So it'd be like 3x squared, 3x cubed, cosine of 3x, e to the 3x, 3 times x inside the absolute value. Sorry about that. So this is the difference between vertical stretching and horizontal stretching. In the vertical one, it's outside the function, right? But with the horizontal one, it's right up against the x inside of the function, right? So this 3 is also being squared, where this 2 was not being squared, right? This 3 is inside the cosine, where this 2 was outside the cosine, right? This 3 was inside the absolute value, where this 2 was outside the absolute value. So that's the difference between vertical and horizontal stretching and shrinking inside versus outside the function, right? So outside the function, you're doing things to the y values. So you should, I do remember talking about this way back when. F of x are the y values. So when you multiply a number by the y values, you're just stretching them. But when you do it to the x values, then you're messing around with the x values and it becomes a horizontal thing. Sorry I messed it up at first, but can I answer questions about that first thing? I don't know if this is helpful or if this is the type of thing people wanted to see. It's still kind of blurry. I'm seeing some people leaving and coming back, maybe because it's blurry. You guys able to see this okay?
I still can't see it. It's wicked blurry. Like, I have no idea what you just explained, to be honest with you.
Is anyone else having that problem?
Yeah, it's really hard to see.
Let me try leaving and coming back
I can't
myself.
even see
Are
it.
you sending the video in HD? Sometimes, like when you I think you might have to reset it every time you go into a call, like the send resolution under
Yeah, I know what you're talking about. Let me see here.
settings.
I'm sending high definition. I'm going to log off and come back.
All right.
Is it any different?
That's much better.
Yeah, that's a lot clearer now.
Okay. Okay, so maybe let me just re-explain that then. So what I did was just write down all the transformations, the possible transformations here. And what I was trying to look at first was the difference between vertical and horizontal stretching and shrinking. And so what I tried to do is write down vertical stretching with a bunch of different examples, and then horizontal stretching with a bunch of different examples. Trying to point out how when you do a vertical thing, the number ends up on the outside, and when you do a horizontal thing, it's inside the function right up against the x. And so you should try to like compare what's in this line to that line and see if that makes sense about the difference between those two things. Can I clarify something about that?
The top part is the horizontal.
The top part is vertical.
Okay.
Because the f of x you can think of as the y value. So like x squared, when you square x values, that tells you the y, right? When you cube an x value, it tells you the y. When you plug in an x into cosine, it tells you the y. And so you're taking all the y values and you're multiplying them by a number, which is different than this one, which is the numbers right up against the x in all of these things, which means you're playing around with the x values, which is a horizontal kind of thing. So let me go on to the next one then. The next one that was at the top here was vertical flipping versus horizontal flipping. So that's multiplying by -1, but again, is the -1 on the outside of the function or is it on the inside of the function right up against the x? Right, and so if we looked at flipping, if you did like minus f of x, and I'm going to use those same examples again. So like minus x squared would be horizontal, or I mean a vertical flip. Minus x cubed would be a vertical flip. But I have minus, I use cosine e to the x. Minus cosine would be a vertical flip. Minus e to the x would be a vertical flip. And then minus absolute value would be a vertical flip. Right, so the negative signs on each one of these things is kind of separate from the function. Whereas if we did it like this, it's going to be right up against the x. So it's going to be inside the square, or it's going to be inside the cosine, or it's going to be in the exponent, right? So it's going to look more like this. So these would be vertical flipping. And this would be the horizontal. So sometimes it looks kind of similar. Like hopefully you can see that like the difference between minus cosine of x and cosine of minus x, that looks very different. And so does the E one. And this one I think looks different too. Sometimes people get confused about this one. Like in this situation, the negative sign is being squared, right? But in this situation, it's not. Right? In this side, the negative sign is being cubed. In this one, it's not. So I'm trying to be careful that it's inside, right up against the x in all three of those examples. Can I find anything about those ones?
So vertical is always when you're doing horizontal or vertical, the verticals is always inside the function. No, outside I meant, sorry.
Yes, it's always outside, right? Anything vertical, whether it's stretching, shrinking, shifting, it's always outside of the function, where everything horizontal is always inside the function. And when I say inside the function, the other way I try to explain that is it's right up against the x, right? Like in this horizontal thing, you're multiplying the x by something, right? In this horizontal thing, you're multiplying the x by -1. In this horizontal thing, you're adding something to the x. So the x, the horizontal, if you look at my hand here, horizontal goes side to side, and x's is what goes side to side. And so when you change something with the x's, that's going to do a horizontal motion. So the last one then is shifting. If we did f of x plus c, this is like taking the function and then adding a number on the outside. So that would be like x squared plus 2, or x cubed plus 2, or cosine plus 2. Oops. Or e to the x plus 2, absolute value plus 2. Right? In each one of these situations, you're like taking the function and then adding something. Taking the function and then adding something. That's different than this, because this, the plus c is going to be right up against the x, and so that would look more like this then. Right, and so these things are all doing vertical shifts, and these things are all doing the horizontal ones. Questions about that? I know Sean specifically asked about this, so I don't know if that's the kind of thing Sean was looking for, but I'm also willing to expand upon any of this with anyone else if there's something else you wanted to look at. If you want to look at a specific problem, or if there was some specific aspect of those things that you wanted to dig into more, I'd be happy to do that.
For the next thing to go over, could you go over it on the study guide when it says problem 11, graphing section? I got hung up with on just how to solve in general for just an entirety of a question.
Are you talking about the review? Is that what you said?
Correct.
Yeah, let me pull it up. Okay. So this is from the review. It's problem 11. There's a bunch of graphing questions. And so the first one says, graph this. So there's three things going on here. The negative sign out front, you got the -1 up in the exponent, and then you got the +1 out front there. And based on what we just talked about, the negative out front is this, right? So it's a vertical flip. The -1 in the exponent, right? We looked at a couple of those. That's going to be a horizontal shift. And to be more specific, we looked at an example that looks a lot like this one. It would be kind of like this, right? So this is a horizontal shift. And so that's going to, and remember, when you do horizontal things, the intuition is kind of opposite. So when you subtract one, it kind of feels like, oh, it should move to the left one. But remember, horizontal is opposite. So when you subtract one, it actually goes to the right one. And then the +1 would be an f of x plus c thing, right? You're taking the function and then adding something on the outside. So that's kind of like this one. And so that's going to be up 1. And so you start with the graph of 2 to the x. And in this problem, it specifically says, be sure to include any intercepts or asymptotes. Excuse me. And so 2 to the x usually looks like this. And it has a horizontal asymptote at y = 0. And so when you do these transformations, you just need to make sure that you're moving around the dotted line too. Right? The dotted line is telling us that this function will never go below that dotted line. And so, for example, when we move it up 1, the dotted line is going to go up 1 with it. So that results in the following graph. So maybe we can do it in stages. Let's flip it first. So let's do minus 2 to the x. So there's 2 to the x. So minus 2 to the x would be the same graph, but flipped upside down. And so minus 2 to the x would be like this. And then we're going to take this graph and we're going to move it right 1 and up 1. And so I'm going to do both of those together since it's just a couple shifts. And so our final sort of image might look something. I'm going to move the dotted line up 1 as well. So the dotted line goes up 1. The graph moves right and up. Kind of hard to show that it moves right, but it's going to do something like this. And to find intercepts, you just plug in 0 for x and y. And so that might involve solving an exponential equation. And I'll do that in just a second here, but let me just see if the transformations look okay. Your questions about the transformations and how we got this, how we started with this, but end up with this based on the transformations?
Where I get confused when it says for asymptotes, like I looked at this as an equation, not for graphing, like to find the intercepts and the asymptotes. So to find the asymptotes, I don't know if it was a fraction, you said equal to 0. So like, I was kind of hung up on how do you find the asymptotes for this just regular problem with no square roots and no fractions.
So it sounds like you're thinking about a domain question or something.
Okay.
Yeah, the asymptote has nothing to, you don't solve anything to find the asymptotes.
Okay.
So with an exponential, asymptotes start right here, and then you move them around as the graph moves. If it was a log, logs have asymptotes here. So if it was a log graph, it would be with something that looks like this.
Which is a vertical asymptote, correct?
Yeah. And so this one's going to move if you move the graph left or right.
Okay.
So, yeah. So for asymptotes, it's not, you don't solve anything. You need to know that where they start. Like this one starts here, and then you move it around as the graph moves. And then with logs, the dotted line starts here, and then you move it around as the graph moves.
And for my intercepts, my x-intercept, I got natural log negative over natural log negative 2 plus 1.
Let's see. Off the top of my head, I don't know. So for the x-intercept, you plug in y equals 0. And so that's going to be setting this thing equal to 0 and solving. And so this is a problem in its own right. Like I might be able to just ask this question independently, right? Like how do you solve that equation? So you isolate the log and then isolate the exponential and take a log. So we're going to subtract the 1, multiply by -1, so it becomes this. And then you natural log both sides. It sounds like you use natural log. Is that right?
Correct.
Okay. You could use log base 2 in this one, and log base 2 is easier technically. But since you use natural log, that's fine. We can do that. So you'd bring this down in front, and you'd get something that looks like this. And ln1 is actually 0, so you can make that go away, but you're welcome to leave it there. And then you want to get x by itself, right? And so you could divide by ln2 and then add the 1. Is this what you got?
Yeah, the only thing I hung up is on your second step. You got rid of -2 and it brought the 1 over and you kept it positive, or it's just the
So I did 2 steps here, right? So you subtract the 1 and you get this, and then you multiply both sides by -1. And then it becomes this.
Why would you multiply both by -1?
Say that again?
Why would you multiply both sides by
because I'm trying to get the log by itself. I want it just to say 2 raised to a power, not minus 2 raised to a power.
Okay, got it.
And that's important because if you left the negative sign there, you'd end up with ln of -2, and that's not defined. So you can't have a negative out in front here. You got to get rid of the negative before you move on to the next part. That's kind of like a small thing. If this is a problem, if this is the problem, I usually make these like 5-point problems. The intercepts might be a point, which means they're a half point each. And if you made like a really small error like that, it would be insignificant, I think, in the grand scheme of your grade. Okay, so that's the x-intercept. And then the y-intercept, you just plug in x equals 0. And so you do y equals, you just plug a 0 wherever it went into the exponent. So it becomes -2 to the -1 plus 1. And I would just leave it right like that. Don't make it any more complicated than you need to. Like, you could simplify this down if you wanted to. It's really not neat necessarily, though. What do you think?
My y-intercept was 1/2.
Yeah, that's fine too. So, no, that's right. So if you simplified this down, you'd get -1/2 plus 1, which is 1/2.
Okay.
But what I'm trying to say is either one of those is fine. Should I do another one?
You just did the following problem, number 12. The second one, 4 sine squared of x equals 3. If you just do that quickly, some kind of jog down my memory.
Yep. So on 12, this is also from review. This is one of the questions. So the way you want to do this is you want to isolate the sign. And so you divide by 4. Right. In all these anytime you have like a sine cosine problem you're trying to solve, you want something that says like sine of x equals some number. Right. So that's what we're trying to get it to. And so we're trying to get sine by itself. So we're going to divide by 4, and then you need to take a square root to get rid of the square. And when you take a square root, you get plus or minus square root of 3 over square root of 4, excuse me, which is plus or minus square root of 3 over 2. And so that's something and the number over here should be something on the unit circle. And so oops, this is not squared anymore. So what we have is sine equals plus or minus root 3 over 2. And now this becomes like a normal kind of problem, right? Where is sine root 3 over 2 on the unit circle? So we want y values that are that. Anyone? Where are the y values? 3 over 2.
Pi over 3.
Yeah, pi over 3s. So all the pi over 3. So pi over 3, 2 pi over 3. These would be the plus root 3 over 2s. And then the minus root 3 over 2s would be 4 pi over 3 and 5 pi over 3. Now, since there's 4 of them in this particular problem, and 2 of them are directly opposite each other, right? Those are directly opposite each other, and these are directly opposite each other on the unit circle. So this is one of those problems where you can just do a pi k thing, right? So you can say x equals pi over 3 plus pi k, and 2 pi over 3 plus pi k. Right, the first one, pi over 3 plus pi k, will account for the pi over 3 and the 4 pi over 3. And then the 2 pi over 3 plus pi k accounts for the 2 pi over 3 and the 5 pi over 3. Because again, they're directly opposite each other, which means they're pi away from each other. So when I take pi over 3 and I add pi, it just takes me over here. And when I add pi again, it takes me back over here. And so when you add pi to pi over 3, it just bounces you between those two values. And when you add pi k to 2 pi over 3, it bounces you between those two values. So this would be the answer. What else can I do for you this morning? I'm happy to look at more problems. I'm happy to like go, if you want just a review of a topic like we did with function transformations, I'm happy to do that. Whatever you guys want, whatever would be helpful. It may just be too that you just finished the homework last night and you're not really starting to study for the final yet, which is fine. But just keep in mind you have you've got the 8.5 by 11 sheet of paper to bring in with you. So as you're studying, if you're like, I'm not going to be able to remember that, just start making the sheet as you go. I would say write really small on it and just try to make the sheet as you go, and just come up with questions. You're welcome to send me questions ahead of time. We can talk about it over the weekend. Or right before class is fine too. But next Monday will be the last day, obviously, before the final to do some review. And so I'd love to make the most use of that time, whatever would be most helpful for you. So if there's anything else, I will sign off. I'm going to go ahead and I will post this video. I might as well. And I will also post the notes I wrote down as well. Anything else?
I have a question.
Yep.
So last night I was working in linear 3.
Mm-hmm.
So where we gotta find the parallel and perpendicular.
Yes.
And what we're having struggle is how to get it from the one question to the other question. So what I was using first was the slope of line to get the first point.
Which problem are you looking at?
Number 8, I believe.
There's only 7 problems in that one.
Oh, it's one of them where I gotta find. Let me see. I gotta open that web again. Give me a second, mister. All right, like for example, just go to problem 1.
Yep.
Where they give you a point and they give you the equation.
Mm-hmm.
And you gotta write another equation for the parallel, and you gotta find another equation for the perpendiculars.
Yeah. Yep, I see that one.
Well, what I was doing first, but then I was going by the notes where I find where I was looking for the slope of the line first, and then once I get the point, I was putting into the point slope of form of the equation.
Yeah, that's fine. So the first thing you need to do on this is subtract I don't know if this is what yours looks like, but you might have a different equation. But you need to make it look like mx plus b, right? Because now we can see that the slope is -3. I don't know if that was an issue, but the slope is -3 of this one, not 3. And so then parallel would be the same. So use the same slope if you want a parallel. And if you want a perpendicular, you do the negative reciprocal. So you would do negative 1/3. Right? So you make it into a fraction and multiply it by -1. So it would become 1/3. And so those would be the two slopes that you'd want to use if that was your equation. And then you're right. Then you could just use the point slope line if you wanted to get the equation. But notice how they want you to enter it. They want you to enter it in mx plus b form. So you could write down the point slope form. So the one I said, excuse me, the one that I pulled up says it wants you to go through the point 7, 7. And so parallel would be y minus 7 equals -3 times x minus 7. That's totally fine, but it wants you to enter it in mx plus b form. And so you would need to add the 7 to the other side and make it look like y equals mx plus b. Right, so you could add the 7. And I think it would even probably accept this, if I'm not mistaken. Because the way that this problem is set up, it says the equation of the line is y equals blank. And so it wants you to enter in y equals form.
Okay.
You can use the point slope form, but you just need to enter it as y equals. I'm just going to check to see if that works. Oops, I entered the wrong thing. Yeah, and it accepts this. And then if you wanted perpendicular, you do the same thing, y minus 7, except you use a different slope. You use 1/3. Add the 7.
Oh, now I see it.
Were you trying to enter it like in the point slope form? I mean, yeah, point slope.
Yeah, I should have broke it down into y equal mx plus b. But
Yeah,
I didn't know you had to get the reciprocal for when you're gonna get a perpendiculars. Now
Yeah. So the perpendicular one is the tricky one because you have to make it a fraction and multiply it by -1. So don't forget, if you do only one of those things, it won't be perpendicular.
Okay. Thank you, mister. What else? I do have another question.
I have a question about the note sheet we can use in the test.
Yeah.
Would it have to be handwritten, or would I be able to type it? Because I find typing it a lot easier.
Yeah, you can type it. That's fine.
Okay.
Quick question, Dr. Lee, since I wasn't here, I wasn't on Tuesday.
Yep.
Is it front and back are we allowed to write on, or is it just the one side?
Yep, you can use front and back. That's fine.
All right. Thank you.
The whole point here is to try to reduce the stress of studying a little bit in these weird times and whatever. And I don't want to just do an open note thing because then people may not study. I feel like when I ask you to make a note sheet, making the sheet is actually, believe it or not, very helpful to learning material. Like I remember when teachers used to let me use a note sheet. Just the act of creating the sheet is like studying itself because you're rewriting down things, you're thinking about what you know and what you don't know. And I would half the time when I make one of those sheets, I don't even end up using it because I made the sheet, so I remember what was on it, kind of thing. So anyway, that's the goal here. Is not, I'm not trying to like limit what you can bring in. I'm just trying to reduce the stress, but also get you to study a little bit.
Yeah. Thank you, Dr. Levy. Have a good one.
You're welcome. I hope anyone else doing anything else this morning. Okay, I'm going to post this. Feel free to keep sending me questions if you have anything. And